All right, hello. Let's go to the next one. This is week one, grind 75, valid parentheses. Now, I hope you didn't see that, but for those who did, it says stack here, which is actually a clue to the answer. This will not happen in an interview. Hopefully not. They probably won't give you the solution or the method. So the way that we're going to solve this is using a stack. Or maybe that's one of the ways. Given a string S containing just the characters open paren, close paren, open curly, close curly, open bracket, close bracket, determine if the input string is valid. The input string is valid if open brackets must be closed by the same type of bracket. Open brackets must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. So, in this example, string, you have open bracket, open parens, close parens. So this is true. It just opens and closes. And then you can have just open, close, open, close, open, close. This is also true. But this opens and this closes a different parenthesis. And that is false. So that's great. Um, the way that I think about this problem is thinking about what skills I'm going to need to solve this. So you're given a string, you're going to want to iterate through the string. For some people, that may, or for some languages, you will probably be well served by turning the string into an array, and then you get a lot of the array functionality. Some languages, that functionality is shared, so you don't have to do this. But in any case, you're going to want to do an iteration over some sequence, right? Whether it's the array or the string. You're going to have some values, and you're going to want to go ahead and iterate through each one, right? And what we're going to think about is what consideration are we going to make every time we get to one of these items, right? So let's imagine one of these items is a open bracket. Do we have to do anything to ensure that the open bracket is valid? Well, in general, you can pretty much open a bracket anywhere as long as it's closed correctly, right? So if you open a bracket and the next string is closed, then it's completely valid two character string, right? These two right here. So you can basically just do that forever. Open, close, open, close, open, close, open, close. Now, what are the things that make this string invalid? Well, what if we started the string with a close bracket? What if that was the first character? Then we know that's actually wrong. We know that that's bad, right? And you can start it with any one of the closed brackets. Starting that invalidates the string. So we have a condition. If it's a closing bracket or a closing, I'm going to use the word parens to refer to all these. If it's closing parens, we have to check that it's valid, right? Check if valid. And what does a check of it being valid mean? It means that it is closing something that happened in the past. And this is where the stack comes in, right? In the stack, we're going to put, you know, you can use any visualization you want. You can imagine you're putting trays on a stack, plates on a stack. We're putting something onto the stack. And the way that we're going to solve this problem is given these characters. So let's just take example 2 for one. We have this, 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 this. As we iterate through these, we can go ahead and we can put them onto the stack. We can put them into the stack. So let's say this is a one element stack. I may need this, so I'm going to save this for later. So we're going to put this open paren on the stack, right? if we're here. So if we're here, I'm going to make this yellow. If we're here at this yellow, we recognize it. It's opening something. We put that on the stack. We can move over, and what we see is this closing paren, and we check if it's valid. And it being valid means the top of the stack is the appropriate opening, right? It's the appropriate opening. So once we see, you know, this is compared to this, right? These two are being compared to each other, and it is a corresponding opening. Then we'd say, okay, in that case, we can actually just pop off the stack, right? The stack could be empty from this point. We iterate to here. This is a new one. Move this over. Iterate to here. This is a closing. We check if the closing is the appropriate one. This matches. Pop that off the stack, right? And as we're moving this yellow one over, this is opening. So it seems like every time it's opening, we put it on stack, right? So if closing parens, check if it's valid. Else, if it's not a closing paren, that means it is an opening paren, we actually put it on the stack, right? Put that onto the stack. Okay, so this matches, and then at the end of it, we have an empty stack. And it seems like having an empty stack is very important, because what if this had, you know, I can actually reuse this thing that I had before. What if this had a bunch of openings that we never got rid of, right? I had one of these, I had a curly, I had a bracket, another curly, another curly, another curly, right? So in this case, it's almost as if the string was open, curly, bracket, curly, 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 and that was the end of the string, right? Or that this was the string, but there was a bunch of other stuff that was closed, right? So if this was appropriately closed, like this, then this is still the stack that we would end up with, right? Because not everything that we've closed empties the stack. So a conditional here, so if the stack has any length, let's just say stack not empty, let's say, then this is not a valid, we don't have a valid closing string. And if it is empty, then we do, right? We've appropriately closed everything. So this would be the functionality, right? We would have some iteration. Well, I'll call it a for loop for now, for let's say x in the string that we're given. If it's a closing paren, so this one, or this one, we check if it's valid. It's a comment. By checking if the top of the stack is the appropriate opening, right? So this would have to be that matching. This would have to match with this, and this would have to match with this curly one. So that's the appropriate opening. Else, if it's not a closing paren, so else if opening paren, pop it stack on the, we pop it, put it on top of the stack. Okay. And this is basically the whole function. So this is a function, I'm going to call it solution, requires a for loop, and then, you know, if we find that this is invalid, we can probably do an early termination, right? If it's invalid here, the whole thing is invalid. For the for loop, if the entire for loop is valid, it doesn't mean we're done. We still have to check if the stack is empty or not, right? And that's basically how we're going to build this code, right? And I'm not sure how we're going to do the stack in Python, but we could just use a list for now, right? We could just take the element that's at the last within the list. Okay, so solution is valid. It's going to have something very similar here, right? For loop check And then we're going to check stack. And in the for loop, we're going to look for closing paren, else is an opening paren, and then when we're checking stack, if empty, it's true, right? This is valid, and then else, this is false. And I believe that should cover, every case. Right, so what is our stack? Well, I'm not sure what the perfect Python version of this is, but let's just use a list. I believe maybe in Python there's a pop. Don't quote me on that. And that's maybe what we're going to use. So how are we going to iterate through this? I don't know if you can do this in Python for I in string. So I'm going to go ahead and I'm not going to use I because it might, indicate an index. I'm just going to use L for letter, or could use C for character. Okay, great. So we can just iterate through the string with a for loop. So it's going to have, I guess this is a overloaded for loop, which accepts both a string and an array, or it's going to use a string as an iterable and iterate through this, right? So let's just make this clear that this is a character. So let's get rid of this print and let's just start implementing. So if this character equals this closing, or the character equals this other curly closing, or the character equals this square bracket closing, then we know that this is a closing, right? So this is a closing, or else we know that this is a opening, right? And if you wanted to see that, if you have one of the test cases here, you could see that when we print the character, we're going to determine whether this is closing or opening, right? This is opening, this is closing for case 1. Look at case 2, this is opening, closing, and that's how we're going to determine our control flow, right? So let's work with opening first because it's the easiest. So for opening, all we're going to do is put this on top of the stack, right? And here, because we're using a list, it's going to be stack dot append. And even though we're using a list, we're using it as a stack, right? So we're going to append the character. Perfectly reasonable. And if it's closing, we actually want to look at the last character in the stack. Now, if it's closing and the stack is empty, it's actually a big problem, right? So we can go ahead and check that right now. The length of the stack equals 0. Let's just return false. Early termination of the whole function, right? Okay. Else, the top element, we're going to call it the stack at the index, which is the last index. And that's going to be the length of the stack minus 1, right? That last element. Else that last element, we're going to have to find the corresponding open brace, right? Open paren. Okay. So what does that mean? That means if the character is paren, so if the character is this one, then if the top element equals this open, then great. Perfectly fine, right? So where are we in the diagram that we have? So if it matches the open, so right here, if it matches the open, then what we want to do is pop off the stack, right? We want to pop off the stack. We want to start emptying out the stack. So if it's open, we want to have the stack, and hopefully Python has a dot pop here. And if it's not, it's actually invalid. This is also another return situation. We already have an invalid thing. This is closing something that it should not be closing, right? So that's for that character. And then we're just going to do this for every one of them, right? If it's this one, then the top element has to be the corresponding, and the corresponding is going to be this open. And if it is, awesome. If it's closing the wrong thing, again, early return. Let's get out of this function. So if the character is a square bracket, same thing, right? Top element is some type of some type of open, right? So it's closing something that it should be closing. Stack.pop. Else we go ahead, return out of this function, right? So if this for loop is successful, right, on the closing, then we're closing everything that we should be closing. And we're doing early return if we find that anything is broken. Go ahead and move this down. We're going to do an early return if we find that anything is broken. Or else we're popping out of the stack, popping out of the stack, popping out of the stack. And we're adding to the stack when we do encounter an opening character. Now, after the for loop, right, remember in this example, we could still have a stack. And that means we have a bunch of open parens that were never closed. So what we want to do is we want to check the stack, and we basically just want to return if these things are, you know, true or false, right? So we're basically just going to return whether or not the stack is, the length of the stack is 0, right? So let's go ahead and run this and test it. But I think maybe it's good practice. I should have not done it yet. Maybe it's good practice to look at the code before you run it. It's actually a bad pattern to run and to iteratively work on this like you would in real life. Because in the interview, you might not have a working console. You might not have this working. And at places like Google, you're just going to get a Google Doc, so you can't run anything. So you want to be able to visually look and see, okay, you have a stack here. We're iterating through the string. We're checking for these special characters, and these are the closing ones. If there's nothing to close, return false. Get out of here. Run. If there is something to close, then we can take that top element, see if we're closing the correct thing, right? Parens closes parens, curlies closes curlies, brackets closes brackets. And then if it's opening, we're just going to append to the stack. And then at the end, we're going to check if the stack is empty. So let's submit this, and hopefully there's no bugs here. But in general, you want to get the idea of this, and that's the important part, before you submit, right? You want to walk through maybe a situation in your head, maybe some of the situations on here. Like this paren, right? This close, this open, maybe some of these, and try to think through things that could break your case. So if a string starts with parens, it's going to break your case. If the string ends with a bunch of open parens that are never closed, it's going to break. This function is going to have to return false. And I guess if there's a bunch of parens that are closed with the wrong paren, right? Or even if there's just one paren closed with the wrong paren, that's invalid. Okay, great.